Hey everyone, and welcome to the second lesson in this video. In this video, we're going to cover the other three inverse trig derivatives and how kind of memorization is going to help you out. I'm still going to solve it the long way, but let's go ahead and show you how it gets done. All right, so right above me, we have arc sine, arc cosine, and arc tangent. And the reason why I have them like this is because we know that they mean the exact same thing. You know that arc sine is written as inverse sine, and that arc cosine is written as inverse cosine. So to help avoid some weird notation issues, you might come across arc sines, you might come across where it says inverse sines, and they mean the exact same thing. So it's important that you guys know that whatever we find or whatever we found in our last video comes out to be the exact same thing here. So we know that these are what the three that we found in our last video. And so arc cotangent, arc secant, and arc cosecant, you can also find using that also very doable triangle intuitive approach, okay? But notice that arc tangent is just going to be the negative option of arc tangent. And then when we have arc secant and arc cosecant, the x squareds and the ones just flip from arc sine and arc cosine. There is also an extra x hanging around. You'll get this when you do that intuitive approach, and you'll see where that x comes from. We just need the absolute value there because we need that value to be non-negative. And then over here, we have, what does it look like with the chain rule? It's just u prime, u prime, u prime up in our numerators. And so with some memorization of this and labeling these very, very well, you will be able to find these inverse trig derivatives a little bit quicker. All right, so let's kind of go ahead and get started. And I know in your notes for this long method that it's already worked out, but I'm going to work it out for us here because I want us to see how do you approach these problems using that intuitive approach. All right, so we're looking for this derivative. And like I said, we're going to do this long method. And so we know that arc sine just means inverse sine. And so basically, if we know that y equals arc sine of 2x, what I can do is swap the x and the y. So the inverse relationship here is the sine of y is equal to 2x. And all you have to do is take the derivative of both sides, all right? So the derivative of sine is going to be cosine of y dy dx, and the derivative of 2x is just equal to 2, okay? Solving for dy dx here, using the same methods that we were using in our last video, we would get dy dx equal to 2 over cosine y, okay? And so now we need to figure out, all right, what is cosine y? So just sketch a triangle really quick. All right, I have a right triangle, I have this, we know y is gonna be this. So we know that the sine of our angles, so this, remember, is sine of our angle is opposite over our hypotenuse. So we know our opposite side of our angle y is gonna be 2x over 1, okay? So our opposite side is 2x and our hypotenuse is gonna be 1. All right, so we wanna use that information to figure out, all right, what is this missing side so that we could figure out, all right, what is cosine of y? That's what we're going to solve for. All right, so we know that our missing side squared plus 2x squared equals 1 squared. Okay, so to solve for the missing side, our missing side is just going to be 1 minus 4x squared, the square root of that. So when we solve for cosine of y is our adjacent side, so our question mark side over 1. So cosine of y, dy dx, is equal to 2 over the square root of 1 minus 4x squared. And it's the long method, right? But it's super intuitive and you can just square these and derive these very, very quickly. So the derivative of arc sine of 2x is 2 over the square root of 1 minus 4x squared. Now let's go ahead and do this using the fast method. All right, so in order to approach this, we need to let u equal the inner function. So u is going to be 2x, all right? All right, so what's the derivative of that? So we'll call that u prime. U prime is just equal to 2. And actually, if you look at our derivatives up here, they all have a u squared, right? So let's figure out what is u squared. So u squared is going to be 4x squared, right? So it's just 2x squared, 2x times 2x is 4x squared. All right, so if we memorize these, that means the derivative of arc sine of 2x equals u prime, which is 2, over the square root of u squared, which is 4x squared, or sorry, not u squared, it's 1 minus u squared, which is 4x squared. So that is going to be the exact same answer, right? Really, I knew I was wrong a second ago because I knew I needed to get the exact same answer here. And I do admit that I struggle memorizing these. I know a lot of the tricks to memorizing these, but I always forget what order these two go in. And if you get that order wrong, your answer is going to be wrong. And you know for sure that that other option is going to be there in a multiple choice. So you're probably going to get that confused. All right. So that's why our approach here, an intuitive approach, is way more to me reliable. But if you can memorize these, you can do these a lot faster, which on the AP exam is going to serve you a little bit better. All right, let's go ahead and move here to question 3. I'm going to approach this one using an intuitive approach. If you decide that you want to use a memorization technique here, you can apply that memorization technique and solve your probably solve the problem and see that we're going to get the exact same answer. But I'm going to show you again that how I approach this every single time. So we know that this is saying y equals arc tangent of 3x. All right, to solve for this, I'm going to take the tangent of y equals 3x. All right, so tangent of y is equal to 3x. I'm going to get my little triangle. Tangent is opposite over adjacent. So this is 3x over 1. So 3x over 1, as long as I put y right there. All right, so what is the derivative of tangent of y? So that's secant squared y dy dx, which equals 3. So that means dy dx is equal to 3 over secant squared of y. Well, now I need to figure out what is the relationship of secant squared of y. All right, so I need to figure out what is this, and we can go from cosine to secant. All right, so let's figure out, I know that I have 1 squared plus 9x squared equals question mark, that missing side, the hypotenuse. All right, so the square root of this, oh, that's squared. The square root of this is going to be the square root of 1 plus 9x squared. All right, so I want secant, and secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse, so we want hypotenuse over adjacent, and my hypotenuse is the square root of 1 plus 9x squared, and my adjacent side is 1. Okay, so dy dx is going to be 3 over the square, so we're going to square this of 1 plus 9x squared, and that is going to be my final answer. And again, if you get this down, arc tangent, you'd have u prime over 1 plus u squared, which is exactly the same exact answer that we got, 3 over 1 plus 9x squared. So again, it'll be a bit of personal preference, but you can see my thought process as long as I know how to do implicit derivatives, you can do any single one of these. All right, we have 2 more examples here, and we could approach this the exact same way, but for these last 2 problems, I'm going to show you again what that memorization technique looks like. Okay, we know that u equals the square root of x. That means that u prime is going to be 1 over 2 root x, because it's the negative 1/2 for the exponent now. And we know we need u squared, so that is going to be equal to u, or just equal to x. So the derivative of inverse tangent of the square root of x is going to be u prime, so that's going to be 1 over 2 root x over 1 plus u squared, so 1 plus x. All right, so let's go ahead and work to simplify this just a little bit. This would be equal to 1 over 2 root x parentheses 1 plus x. And again, a bit of personal preference. Do you decide to memorize all 6 of these inverse trig derivatives and throw that in there with all the other things that you need to memorize? Or do you memorize an approach, a conceptual understanding to these trig derivatives, inverse trig derivatives, and then do you approach it that way? And finally, our last option here, we're going to be looking at this for a chain rule. So let's go ahead and look at this, because we have actually 2 chain rules happening. We have our exponent happening first. All right, so when we take this derivative, we're going to go bring the 2 down, and I'm left with secant, inverse secant of e to the 2x, now times the derivative of the inside. So times the derivative of inverse secant of e to the 2x, which has another chain rule inside of it. All right, so when I look at this, this is the part that has the inverse trig derivative. So the first part with the exponent of 2, I just did a straightforward normal power rule. Held onto the inside. Now I am multiplying it by the derivative of the inside. So the derivative of inverse secant, that's where I'm going to be pulling up our memorization techniques. All right, so we know that u is going to be e to the 2x, and let me write du over here. That is going to be 2e to the 2x when you apply a chain rule inside of that one, okay? We also need u squared, and so u squared is e to the 2x squared, so that's just e to the 4x. So I have all the parts here that I need, okay? So this derivative is going to be equal to 2 inverse secant of e to the 2x times, all right? So then again, memorization technique, let's say you memorize these inverse secant rules, okay? So arc secant is u prime, absolute value of u, square root u squared minus 1, okay? So we're gonna write that over here. U prime is going to be 2e to the 2x over absolute value of u, so e to the 2x times the square root of u squared, which is e to the 4x minus 1. Well, the absolute value here doesn't really change anything. E to the 2x will always remain positive, all right? So if I have e to the 2x over e to the 2x, those are going to divide out, okay? So we could simplify this a little bit. I have 2 times 2, which is going to be 4 inverse secant of e to the 2x. Those e to the 2x's divide out, and my denominator is now going to just say the square root of e to the 4x minus 1. And that is going to conclude this video. We can see that in some cases, if you memorize these, you memorize this approach, you might feel a lot more confident about answering these quickly. Okay, but I don't really have a lot of memorization techniques other than the fact that the C's are all going to be negative, and then you just have to kind of figure out is it 1 minus or 1 plus or x squared minus or x squared plus, and then you have to just memorize that part of it. Okay, so I leave that memorization up to y'all if that's the approach that you want to take. We can see how complex chain rules can still pop up in these cases, but I feel confident in your abilities after unit 3 to apply the chain rule when needed. Of course, if you do have any questions on this section, you can always reach out to me. I'm Mr. Hernandez, and this is Mr. Hernandez Teaches.